Prison school like that one. And we found out that Mutally
We're going to do three things today. We're going to find some simple probabilities, finding some mutually exclusive probabilities, and finding non-mutually exclusive probabilities. In fact, we have done two of these, but we're just going to review them a little bit. Finding a simple probability is nothing more than taking your desired outcomes and dividing by total outcomes. That's all a simple probability is. Such as if I tossed a coin and I wanted to get heads. Okay? If I took a single coin and tossed it, what would be my total number of desired outcomes?
2.
Desired outcomes.
1.
Desired outcomes would be 1, right?
Yeah.
The total outcomes from a single coin is 2. So the simple probability of tossing a coin, no matter how many times I toss it, of getting a head would be 1 out of 2, or a half. If I took that same coin and tossed it twice, this one is kind of the non-mutually exclusive, but it's also simple probability. The first time I tossed it and I wanted to get heads, what's the probability of getting heads? 1 out of 2, isn't it? Right? What's the probability of tossing it again and getting a head? 1 out of 2, isn't it? How do I find its total probability? If it's two simple ones, I multiply them together and my total probability becomes 1 out of 4. How can I demonstrate that? Well, if I toss the two coins, couldn't I get a combination of a head and a head? I could get a head and a tail. I could get a tail and a head, and a tail and a tail. How many total outcomes do I have? 1, 2, 3, 4. Right? I have actually 4 total outcomes, and I wanted a head and a head. There's only one of those, right? So I'd have 1 out of 4. Would be another way of showing it by a diagram. Okay? Other simple probabilities, desired outcomes over total, would be, let's say I have a bag of marbles. I have 3 red, 2 green, 4 blue. If I reached in the bag and I wanted to get a green marble, so my desired outcomes would be 2 out of what's the total outcomes? 9, because there happens to be 9 marbles, right? Okay? What if I replaced it, and then I wanted to draw a blue one? Wouldn't I have 4? And if I replaced it, 9 again? Do you agree? Well, if that's the case, what's my total probability that both those things would happen?
8 over 81.
I multiply them, I'd have 8 over 81. What if I started with that same bag of marbles and I wanted to draw 3 red ones,
3 over 1.
but I didn't replace it? How many total marbles would I have then? 8, and the next time I wanted to draw a green one. Be 2 out of 8, wouldn't it? Which means that my total probability would be 6 over 72, which I can reduce to 1 out of 12. Okay? What are we talking about when we're talking about mutually exclusive?
Depends on something that's happened before, right?
Actually does not depend on anything before. Such as, mutually exclusive would be if I wanted to draw in a deck of cards. I wanted to find the probability of drawing a jack followed by a number card. Those are mutually exclusive, aren't they? Because the jack is completely different from a number card.
What's the B?
Probability. Okay? What if I change that to finding the probability of a jack that would be a heart? That's non-mutually exclusive because I can actually draw a jack and I could draw hearts. Well, wouldn't part of those hearts be jacks?
Yeah.
There's a possibility of that. So that's non-mutually exclusive. So if I go back up here finding a mutually exclusive one, if I wanted to draw a jack, how many jacks are in a deck of cards?
Oh,
There are 4 jacks, right? And how many are in cards are there in the deck? 52 cards. So this would be my probability of getting a jack. Okay, and the number cards, which would include, some people consider ace to be a number card, some people don't. So which way do you want to do it?
no. It's a number card.
Oh, it doesn't have a 1 on it.
Doesn't have a 1 on it. So we got 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You got 9 of them in each suit. Would you agree? And how many suits are there?
4.
So I have 36 desired outcomes, right? Out of still 52 cards, correct?
So you replace the jack, right?
Didn't have to, but in this case we did. We replaced the jack. How do I find if they are mutually exclusive? I do not multiply them together anymore. I add them together. So to find this total probability, by adding, I'd have 4 over 52 plus 36 over 52.
40 over 104. 52. 40 over 52.
When you're adding fractions, you never add the denominators, but they have to be the same. That's why I replaced the cards so that I didn't have to find the common denominator between, yeah. Can this be reduced?
Yup. Oh, look at you.
10 out of 13. Okay? Does that make sense? From that? Okay. What if I had a dice and I wanted to toss it a couple of times? On the first toss, I could get a 1 or a 3. And on the second toss, I wanted a 4 or a 6. Would these be mutually exclusive?
Yes.
Yep, they would. So on the first one, what would be my probability of tossing a 1 or a 3?
1/3.
1/3, or it started out as 2 over 6, right? And over here, what's the probability of getting a 4 or a 6? 2 out of 6, or 1/3 also? What would be my total probability? I'd have 1/3 from here plus 1/3 from here, which would give me 2/3.
So mutually they do depend on each other, right?
They don't.
And not-
There is nothing common between them.
Okay.
Does that make sense?
Yes.
Nothing common between them. A dice is another way of looking at some that are non-mutually exclusive because of the fact that, let's say that I tossed a die and I wanted a 1 and a 2, and over here I wanted a 2 and a 4. There's actually something in common between them, right? So this is non-mutually exclusive. So I would toss this one. I would have a probability of 1/3. Correct? Over here I'd have a probability of a 1/3. But because they are sharing something, I have to subtract from this the probability of the shared, which would be 1/6, because the 2's share. There's one of them.
How do you get 6?
Well, when you toss a dice, how many,
Oh, gotcha.
right? When you toss a dice, don't you have 1/6?
Gotcha.
Does that make sense?
Yeah.
So it'd be 2/3 minus 1/6, which would be
2/3 minus 1/6
4/6.
minus 1/6.
So it'd be 1/2.
So it'd end up being probability of 1/2.
I actually understand this, I just finished my main.
Yeah, we get some denominator between.
They had like 6 problems with this, and I forgot completely how to do it.
Remember when we talked about that? Okay, this is no longer mutually exclusive because there is a jack that's a heart, isn't there? Okay, but can I find the probability of drawing a jack?
Yes.
Yeah.
4 out of 52, correct? What is the probability of drawing a heart? 13 out of 52.
52.
There are 13 hearts, 13 spades, 13 clubs. What's
13
it?
of each card.
13 diamonds. right? Okay? Correct? Now, since these probabilities, I need to add them together, right? But I need to subtract from that, what's the probability of there being a jack that's a heart? 1 out of 52, isn't it?
He's picking cards.
So if I add and subtracted this whole thing together, 4 plus 13 be 17, minus the 1 out of 52, which would give you 16 52-seconds, or 4 out of 13.
Well, now remember that 13 is divisible, 52 is divisible by 13, because I